Studying worlds, 4 inner planets. My very excellent mother, Venus. It's time for you, Venus. You're up. We can compare those, contrast those. Let's do Venus. Which one is it? What do you know? Pause, guess. In the book, I have you guess. Do some activities. Venus is that one. My very excellent mother. So what do you know about it? Width, size, and distance. So what could you guess? Quite a lot, right? So the story of Venus is the Roman name of the goddess Venus, the Greek name Aphrodite, goddess of love and beauty. And the story is that you might say that's a woman with head and arms. Remember, we had Mercury with the wing and helmet, so it's like a person, looks like a person. But also the story is that's a hand mirror, like, oh, aren't I looking nice today? After all, I am the goddess of love and beauty. But the theme for Venus is looks can be deceiving. Venus is a beautiful dot in the sky, just beautiful. Sometimes out in the evening, sometimes out in the morning. Mistakenly, and still today, some people say it's just, the word star really means kind of a glowing thing, but now we've refined it to mean what we think of as a star. So now we would really say it's the evening planet or the morning planet, the really bright one that's very beautiful to look at, but looks can be deceiving. So let's talk about that. Let me make sure we're good here on our Zoom. Come in a little closer. All right, I know there's a little glare over there. Tell me if it's too bad. What have we got? Moon, 4 across, 4 across, 4 across. Mercury, 3 across, 3 across, 3 across. Very similar worlds, right? Except the inside, but lots of similarities. Don't stop too superficially. And then we've got Venus. Why do I like this for Venus? Because it's all murky, right? All murky over here. Venus. So let's take a look at Venus, and we're going to take a look at some pictures of Venus. I want you to think about what Venus would be like before going to the pictures and the videos. Okay. So, you know, the diameter with the Venus, as you saw, was, well, obviously these are props, but it's about 1/1 using the simple fraction memory aid. Real answer is 0.9. No one cares. You don't have to remember that, right? A little bit smaller. So it's big, like Earth, compared to the other ones, right? It's big. And we know Earth is still warm inside, and we also know that everything formed together, and we know the steps. Chapter 7, that's why, right? It formed together. So it's going to have more hot stuff inside and more radioactive stuff inside, right? So it's big. Its inside is still warm, and what does that mean it is? What do we say when a planet is probably warm, hot inside? We say that it's going to be, we expect it to be active. Geologically active, right? Could there be life? Could there have been life? We wonder. We'll talk about that. The surface gravity, about the same size as Earth. So what would you expect? Like Earth's. About the same as Earth. Couldn't jump much higher. Real answer, about 0.9 times, so a little bit less than Earth. So you can jump, it's a little weaker gravity, you can jump a little higher if you're in a room like this and protected from the outside. Okay, so that makes sense. That tells me that, and it tells me that kind of makes sense. Okay, cool. So walking around on a moon, we'd feel real, especially in a room, not wearing a spacesuit. It'd be kind of wild. You push off the ground, you just go way up. Mercury too, but not as much. And Venus kind of seems similar. You could play basketball and feel pretty strong. What about distance from sun? You see it 1/3, 2/3, 3/3. So you know this one, 2/3 of an AU, about good enough, right? Simple fractions. From sun, that means it's close to sun. That means it's going to be a hot surface. We expect it to be hot, right? Hotter than Earth. Right? And as I said, if this was sun, take about 10 long steps. I mean long steps, if you can, 10 meters or so. Go out there, and that's Earth. Go about 3.5 or so, and you get to Mercury, and another 3.5, you get to Venus. Little specks of sand, right, compared to this, and then another that bit out to Mars. So you might set that up. Out to Earth. We'll talk about Mars later. Motion. Well, it's closer. So Kepler's third law tells us that it's going to have a shorter distance around sun, and it'll travel faster than Earth, but slower than Mercury, the messenger. And so what does that end up being? Well, not such a great memory aid here. Venus can give us problems. And so about 8 months to orbit. Remember that. So how long to go halfway around? I'll show you. And then what about spin? What's going on with the spin? It's slow. And it's nearly the same, around 8 months. And so what is that? Approximately a synchronous spin orbit like whom? Like Moon. But Moon was how many days? About 28 days, right? Not exactly, that's fine. So it's in a tidal lock with Sun. Not exactly. I'm going to talk about something kind of cool with Venus. Now, is it tilted? Not really. Much of a tilt. Not getting much seasons out of it. So, shoot, it was kind of Earth-like. We were going about the same size as Earth. It's still warm and active. It's similar gravity. This is cool. You know, it's a little warmer, so maybe it's tropical. Maybe it's got great fruit. Maybe there are dinosaurs. Maybe there are Venusian, restaurants. And, people wondered. And it hasn't been that long that we've known, right? So it's kind of cool. I mean, people wondered. It wasn't until the 1900s we started sending radio signals, et cetera, and then looking closer, and then being able to send rockets out, when we start getting into that transition period, World War II, and 50s and 60s, and we talked about that, Apollo missions and all that stuff. So we haven't known that long, and you would be reasonable to wonder if Venus had life. And we'll still have that question in a second, but let's take a look. So get to know it. So that's interesting. Its size kind of tells you this. That makes sense. It's closer, so we'd expect it to be warmer. We'd expect it to take longer than Mercury, but not as long as Earth. Interesting that it's in this synchronous spin orbit. No season, so that's kind of lousy. But there is a hey to this. Actually, Venus spins backwards. So you could say that it was spinning. So why does it spin backwards? So you can write that, spins backwards. That's the hey. So what does that mean? I mean, if everything is orbiting Sun and spinning this way, and moons are orbiting this way, for the most part, not all, there's kind of a sense to that in the creation of our solar system. What would make Venus spin backwards? Well, maybe it was spinning the same way, and something large came and hit it, or just gravitationally pulled it over, and maybe it just flipped. Maybe it was going the same way, but it flipped, and now it's going the other way. Maybe something hit it and reversed its spin. The trouble is, to answer that question, we need some evidence. We can model that. So, I haven't got a simple answer for you. We just know that it is. So that's a cool thing about Venus. Know that. Let's take a look at Venus, and maybe we can answer some of these other questions about magnetosphere, atmosphere, surface. So let's take a moment to take a look with our good friend Galileo. Looking with a telescope now, right? Because you can't see this with your naked eye. I mean, Venus is beautiful, bright, bright. Look in the book, find the magnitude. What is the apparent magnitude of Venus? It's kind of neat because it's always bright. It's always bright. And so when it's mostly lit, the part facing us, we know everything's half lit, right, in the light. But the part facing us is mostly lit, it's small. So it's mostly lit, but we don't have much of it. And here it's only a bit lit, but it's large. So that's interesting. Maybe this ends up being the same area as that. And to our eye, it kind of blurs out, and we just see this beautiful dot in the sky, not a star. It's called a morning and evening star, but not. So that's interesting. And Galileo looked up and he saw this, and he said, hey, this must be far away. And it's over here, so I have the lit part facing me, and as it comes over here, not much of the lit part is facing me, but it's going to look bigger because it's closer. Oh yeah, it must be orbiting sun, heliocentric, chapter 3. Okay, so what are we doing? Now this I think, is cool. So these pictures were taken, here we go, February 2004. Now this is the day and the month, as a lot of people around the world do, which makes sense to me actually. Day, month, year, we know what the month is, so you can just tell me the day. And if I go from February 2, 3, right? Venus is over here, it's coming around, and it's going to come over to be here. So the not lit side will be, let me do this, right? If this is sun, the sizes are wrong, obviously. But whatever side is facing sun is lit, so you're going to see, you can see it, right? Whatever side is facing sun is lit. As it comes around, you're going to see it be a bit lit. Oh, yeah. But it's going to be closer, so it's going to look bigger, and this will look smaller, right? Doesn't it? To you? I think it will. I got to project that, right? How long does it take to go around? Halfway. From full, or which is hard to see if sun's there, ever gibbous over here, to crescent. How long does it take to go halfway? How long does it take to go all the way around? Pause, look back, 8 months, right? 8 months. Interesting. How much halfway around? 4 months. What's 2 plus 4? 6. 6. I think that's kind of cool. All right, so anyway, we don't get a great view of it until we throw on some optical equipment. Take a look at this view. Oh, I'm in the way, aren't I? Where is Venus? That's Venus. What are these? These are just markers of where it was. So these are markers. Venus transit. Now, it happened in recent history a couple times. If you missed it and you weren't up at a star party at your campus or at home, then you missed it for your lifetime. It won't happen for a while, but you get to see these pictures. Events are fun. And that's Venus. So think about Venus. I mean, what? There's Venus. Earth-like, right? Now we know it would be 1A, a third of an AU to Mercury, 2/3, and then us. So it's here, and Sun is here. If we moved it back twice, it'd be smaller, right? So it's really, compared to Sun, if you put it right next to it, would be smaller. But it's an Earth-sized world that's a bit closer to Sun. And again, you know, grapefruit, tropical fruit, you know, resort towns. What's going on? What's happening? What kind of music do they listen to? What sports do they play on Venus? Earth is one of those. Now, if you have the right filters, this is 2004 also, same time as that other one. Venus, and you wonder, and this is Sun. Huge, right? A star. Venus is not a star, right? Not in the modern sense of the word star. So what's up? And then we go. So we want a better view. Well, you got to go. I mean, telescope's fine. You can see it go through crescent phases, but we want to go. And you go, and here you're traveling to Venus, and this is what you see. A yellow, brownish, yucky, swirling gas. You can't even, remember Mercury, you can see the surface. Moon, you can see the surface. Venus, you can't see the surface. You cannot. You can't see the surface. It has got the thickest atmosphere, and we're leaving out the outer planets and discussions there. Of these four, we've got a thick atmosphere. Okay, let's come back and talk about that. Let me get a better view of that. That's much better. Sorry. There you go. Good old internet, right? You can just do that too. So let's discuss it and then come back and for some more pictures. So what's up, Venus? What about magnetosphere? What do you think? To protect from the solar wind. Well, we got Earth. It's warm inside, so is it warm inside? Yeah, sure. Yes. Has it got a fast spin? Slow, right? No. And so magnetosphere, kind of surprising. Yeah. Without, again, getting into whatever subtleties you want to get into. But so magnetosphere protect from the solar wind. That's an interesting thing too. See, it's a combination. It's not one thing that determines what happens here, right? We'll get into that a little bit with Mars. What about an atmosphere? Yeah. So yes. And let me say, yuck. Okay, so we'll talk about that. Why does that make sense? Well, I'll go through my checklist. Is there going to be gas coming out from a hot interior? Well, it's just same size as Earth, so it makes sense. We're still active. It's still active. So I got a big yes here. It needs enough gravity to hold the gas. It's almost Earth's, right? Almost Earth. So yeah, it's got enough gravity. It can't be too hot on the surface. Now it is closer, so that's going to make it harder to hold on to, being closer to Sun. But still, we're okay there. Clearly we're okay because you see that Venus has an atmosphere. And so to finish, kind of to hit this sort of fast, and then we'll take a little tour. So what do you see on the surface? I'll show you some pictures. But one thing that you will find on the surface, that the temperature is, who would be hotter, Mercury or Venus? Ask your friend, what would be a good guess? Well, if they knew my very excellent mother, then they would say, Mercury's closer. Venus is twice as far away. Venus is the hottest planet because it's close to Sun, but it's got a thick blanket close to sun, thick blanket. What does that give it? A runaway, it's called a runaway greenhouse effect. Runaway greenhouse effect. Some think and wonder if Earth isn't going to end up like this. And I'll show you what it looks like on the surface down there, and we'll check out that fruit. So what's it dominated by? It was still hot inside. So it turns out, I kind of like this. That's how you can remember it. But that's an A. It's dominated by volcanism. You can use a U there, actually, if you want to use that god of fire. But volcanism, feature by name. Check the text for a name of a volcano that you might be held responsible for. Volcanism. So this is the release gas and lava through cracks and volcanic mountains. So I should put that in there somewhere. Volcanic mountains. Volcanic mountains. Oh, do it like this. Whatever. And cracks. And what does that release? Well, it releases the gas. And what does that give you? Atmosphere, yeah. Thick atmosphere. A thick atmosphere. And do I want to say it here? High temp. And pressure. And that, think of carbon dioxide and acid rain. So the connection makes sense in that Venus is still a large and active world. It's releasing gas. So volcanism makes sense here. And we'll talk about this a little bit more in just a second. And that will release that gas. It creates a thick atmosphere of carbon dioxide. Remember how the steps, like the simple, without getting into much detail, of how our Earth atmosphere formed, releasing from the inside a lot of carbon dioxide, right? Nitrogen, other stuff too, but dominant. And then acid rain, there's layers of the atmosphere here too. So I'm going to talk about this in a moment, but let's take a peek back over here at Venus. Do a little better job there, okay. So yeah, there's layers. It's just really, really nasty. Remember that. Think about landing and going through that. We'll talk about that in a second. Okay, I'm going to come back to that, actually, to finish this off. Almost there. So I think a very interesting point here is that we expect the interior to be like Earth with iron in the center and a rocky mantle. I mean, liquid iron, but not spinning fast, right? So that's interesting. But, and I'm not going to write this, I'm going to say this. Earth is covered in water. Was Venus ever covered in water? People wonder that. People are getting data, seeing maybe, and it seems like people are kind of leaning towards that. And maybe that's enough evidence where we conclude it. I don't know. This gets kind of interesting when you understand all this. Earth's water softens the crust so it can crack and move around, plate tectonics, right? But what happens is Earth's softened crust, can move around, it can crack, you can let the berry filling out of the pie. But here, Venus is dry, and that pressure builds up and builds up and builds up. And it releases through volcanism, right? But it doesn't move around and have quite as much release, right? So it builds up. And every so often, you can look up, 100,000 years-ish, 500,000 years-ish, look this up, it seems to resurface. Now, what does that mean? Venus resurfaces? What if there were cities? What if the dinosaurs are down there? The cabana, the resort, it's under the surface. It's been, there was such a great jazz club. It's all been resurfaced. How would we know? I mean, we would look for signals, right? Something. And but it's crazy. The Venus resurfaces itself. Why? Because it's dried up. It's more rigid crust. So have we gone? Yeah, we've gone. Lots of missions. Not as easy to go to, as you see. The Soviets went there, and we started going Apollo missions. Late '60s, the '70s, and the whole Cold War thing is interesting. That goes on. And the Soviets tried to land, and then they failed, and they tried to land, and it's fun to listen to the scientists, engineers talk about this mission. And when they land, there's high temperature and pressure, so stuff starts to melt and be crushed. You basically be lucky to last an hour to 2 hours. I mean, forget it, done. You can't rove around like you can on Mars or Moon. So you want to send people here, you better not like them. I mean, how are you going to do that? So we could do flybys, right? And as you fly by, you get to see it, like we did a flyby of Mercury and saw half of it in 1974. Right? You could land, yuck, but got some data there, right? Or you can go into orbit. In 1990, a really great mission was to send the Magellan mission up and just use radar. So if you're using radar, then like in a boat for the ocean bottom, whatever, if it doesn't take long for your signal to come back to you, then it must be shallow, and if it's deeper, it takes longer to come back to you. So you can time how long the signal returns, and you can really map out fine detail, and I'll show you those pictures. So missions, questions, mystery, puzzles to solve, and it can, again, influence our understanding because you build better technology and a better understanding of the factors that make things the way they are on Earth or different. And so let's take a quick tour of some pictures to finish this off. And that is your Venus. Yuck, runaway greenhouse effect. There's the Magellan mission, 1990. Heading off to Venus. Mapping Venus. Now, you'll see, and I've shown you a picture where you have Venus colorized. That's not the color of Venus. That's colorized to bring out these details. But look at this hot stuff coming out and flowing out, right? See these flow patterns. You can tell the flow patterns. Right, look at that. Hot stuff pushing through volcanism, right? Gas, atmosphere, and lava, hot rock. And you can build them up big volcanoes. I won't go into that on this video so much, and you can see it. If you don't colorize it, you find that it's quite gray, like Moon and Mercury. Quite gray. And you see features that you don't see on Earth because it's a little different situation. I mean, it's interesting, again, geologists go crazy looking at the differences because there's so much information and stories within the rocks and the minerals and how they chemically form and blah, blah, blah. And, you can get into that if you like. It's just studying. There's features you don't see. This is often called the tick. right? Kind of mouth and legs or something like that. So that's interesting. What makes this? That's the mindset of the planetary geologists. And here's where the aliens live. Don't tell anyone I told you about the aliens there. And look at this picture. Now this picture is cool. This is the same spot taken, I forget, it's a short time afterwards. So if you're looking at the exact same spot, notice it changes. What does that tell you? It's changing. It's active. It's warm inside. We haven't seen a volcano go off, but maybe that's because we haven't been looking much, right? So that would be pretty cool. Windswept, you'd think with this crazy atmosphere that you might have a lot of wind. There's certainly, you've got some convection and stuff, but it's not that much. You've got a slow spin, right? You've got a slow spin there too. So, again, there's details to be studied. An interesting world. Looks kind of like water flow, right? It could be lava flow. So you gotta get into the details to answer those questions. And that's your world. That's Venus, goddess of love and beauty. To which I say, beautiful to look at from afar, but you don't want to get too close because it's a pretty hot, heavy pressure, thick acid rain, runaway greenhouse effect world. I hope Earth doesn't go to that, but we will see.